Hey guys, this is Mr. Gran, Geometry Sections 1.4 and 1.6, Inductive and Deductive Reasoning. In this lesson we're going to be talking about inductive reasoning. So what is inductive reasoning? It is reasoning that makes conclusions based on patterns and examples. So we'll see what that looks like in a minute. Can you extend a pattern? So looking at this, using inductive reasoning to find the pattern, find the two next terms, or the next two terms, right? So I want to look at this and I want to figure out what the pattern is here, right? So 88 to 82, well, that's going down by 6. Now I don't want to just stop there. I want to see if that pattern holds, right? So from 82, if I do minus 6, do I get to 76? Yeah, I do. And if I minus 6 here, I get to 70. And if I minus 6 here, I get to 64. So I have a consistent pattern, right? So the next two terms then, well, I would just minus 6, and that equals 58. And then another minus 6, and I get to 52. And so those are our two answers. All right, if you want to pause, try these ones out, and then unpause when you're ready. All right, so looking at this one, get to 3 to 5 is a plus 2. From 5 to 9 is a plus 4. From 9 to 15 is a plus 6. So this pattern is a little bit more complicated than the last one. That's why we don't want to just do a plus 2 and then do like 25 and 27, right? We got to make sure that that pattern goes all the way. All right, so then the pattern here is I'm doing plus 2, and then it's increasing by 2 each time. So that plus 8, now it's going to be a plus 10, which gets me to 33, and then a plus 12, that gets me to 45. Looking at our next one, all right, 80 to 400, well, that would be subtracting by 400. Then 400 to 20, or to 200, that would be subtracting by 200. 200 to 100 is subtracting by 100. Now, that is one pattern, and we could continue to do that. I'm subtracting half each time. Another pattern that we could maybe see with this is that we are dividing by 2, right? So this divided by 2 is 400, divided by 2 is 200, divided by 2 is 100. Now, if you did it the other way, you could still get it right. But this, to me, it's a little bit easier, right? So then 100 divided by 2 is 50, and 50 divided by 2 is 25 for the remainder of that pattern. All right, a little bit more vocab. Conjecture. A mathematical conjecture is a statement that we believe to be true, right? It might not be, but we think it is. And counterexample, well, that would be something that shows that the conjecture is false. So if I can come up with an example that says, hey, that doesn't match whatever my conjecture is, that is called a counterexample. All right, so looking at this, determining whether or not this conjecture is true, and then if it's false, giving a counterexample. So the sum of two decimals must also be a decimal. Now, what I think they mean by this is if I had something, a number like 1.1, that's a decimal number, and 1.4, let's say, that's another decimal number. If I add both of them together, do I need to have a decimal point for those? I don't think that's true. I think I can come up with a counterexample. So I think this is false, and a counterexample could be something like 1.1, let's say, and let's add a 1.9 to it. Well, then if I add these two together, what I get is 3 without a decimal. I don't need a decimal, so I maybe wouldn't consider this a decimal number, okay? Let's see, and then a number must be divisible by 2 if the last digit is an even number, right? Well, maybe I try to figure this out. Maybe I try to find some counterexamples first. So like, what's 13 divided by 2? That's an odd number. Do I get, is it divisible by 2? It's not. That's 6.5, excuse me, right? Maybe I try another one. 29, let's say, divided by 2. Well, that's 14.5. So all these odd numbers, all these numbers where the last number is odd, I keep coming up with these 0.5s. I bet that this one is true. And if we wanted to keep trying for counterexamples, we could, but we kind of know that. If it's an even number, it's divisible by 2. That's kind of a known truth. So I think we can call that one true.